welcome to Sham Civil Academy. In the last class, we discussed about what is the aim of strength of materials and what we will find out of strength of materials. Now, we will discuss about simple stresses and strains. So, what is this simple stresses and strains? This is the first chapter of the strength of materials. Here, we will get to know about what are the types of loads, what are the types of stresses, and what is stress, and what is strain, and what are the types of strains, and different material properties. So, let us discuss one by one. So, load. So, load is nothing but some force which is acting on a body. In physics, we will discuss it as force, but here in strength of materials, we will discuss it as some amount of load. Okay, here the units is newtons. So, the load is acting perpendicularly here to the axis of the material. So, the loads based on the direction and based on the time they acted on a body is divided into two types. Here based on, so the load is divided based on direction and the amount of time which is acted upon the body. So, direction, based on direction, it is normal load and shear load or transverse load. Based on time, gradually applied load and sudden load or dynamic loads. So, here these are the main classification of load, how the load is classified. Based on direction, if it is acting normal, perpendicular to the axis or perpendicular to the surface, then we will call it as normal load. Whereas shear, here if the surface is in such a way, it will act upon the surface, parallel to the surface. Here perpendicular to the surface, here parallel to the surface. If the surface is here, if this is your surface, it will act like this. Okay. For an example, for a shear load in a real life, if you cut a cake, so the cake surface here, so the knife will goes in this direction, right? So, here if you cut it upon, for this surface, this is normal load, but for this surface but for this surface it will become a shear load because the knife will go parallel to the cake surface. So, that is why it is called a shear load. Based on the time, gradually applied load or static load, here gradually applied load or static load. So, they do not act all at a sudden, they will rest on the body like a dead weight of the body. So, there are gradually applied loads, but whereas in sudden load, it will take very less time and the impact, they will act as from a certain distance on the body. So, those are all called as sudden loads. So, the sudden load will makes the body to feel more load because of the distance which is from from certain distance. If it is fall, it will create more impact on the body. So, that why these are called as sudden or impact loads or dynamic loads. So, sometimes they are also classified into moving loads, but for time being we need to know about this normal loads and shear loads. And normal loads again classified into based upon the direction. So, if they act towards the body, they called as compressive loads. If the normal loads are acting away from the body, they are called as tensile loads, right. So, if they act towards the body, they are compressive. If they act away from the body, they are tensile. And whereas shear also, shear is divided into two types. So, axial shear loads, if they act, if this is the surface, if this is the axis, So if they act based on the axis, they are called axial shear forces. If they act with some distance from the axis, they are called as eccentric shear loads. Okay. So based on this, the load is nothing but some force acting on a surface here. So we will notify it as newtons, or sometimes they will be notified by kgs also. Okay. So this is the main classification of loads here. Next, what is stress? Stress is nothing but if the load acted on a body. Okay. Now we will get to know what is load. Load is nothing but simply a person standing on a earth. If he weighs 60 kgs, so he is creating a load of 60 kgs on the surface. If this body is able to take it, is able to resist the load, then it will be in stable condition. Right? We are standing on the earth surface. If it is strong, what it will do? It will absorb all the load and it will give us stability. Okay. So here the material earth has some stress. So here the material earth has some resistance. So that resistance offered to a load is called as stress. It is denoted by sigma, right? So the resistance which is offered to the load acted upon it is nothing but stress. Okay. So here the pressure is different and the stress is different. The pressure means pressure acts only on the body, but the stress is internal resistance to the external load. Okay. So that's the difference. So here we will denote it as sigma. Okay. So stress is also classified into two types, that is normal stress and shear stress. So if the normal loads are acting on a body, if it gives the resistance to those normal bodies, that is called as normal stress. If the shear stress acted upon a body, the resistance offered to the shear load, it is called as shear stress. Okay. Simply the stress is sigma. Stress is denoted by sigma and the units is nothing but P by A. Here load by area, load divided by area is stress. Load divided by area is stress. So load, as we discussed earlier, P means load units newtons, area unit mm square. So Newton per mm square is the units for stress. So here the classification is two types. Okay. Next, what is the strain? So strain is you are applying some load, that is tensile load, right? So after applying the load, it will extend a bit, right? It is expanded by delta L. Okay, this is the total L. So for example, so take this bottle cap. Okay, we are applying some tensile load, right? So we are applying. Initially it is L. So initially this is like L, and we are applying the tensile load. So what will it undergo? It will undergo some deformation, that is delta L. So this change in dimension to the original dimension is known as strain. So what is the change in dimension? Is delta L by L, right? So this delta L by L is nothing but strain. It will have no units, but the strain is again divided into two types, that is longitudinal strain or lateral strain, that is normal strain simply. So normal strain and shear strain, right? So what is this normal strain? normal strain means if the normal load acted upon it. So this is a normal load, right? It may be tensile or it will be compressive. Sometimes it may be compressive. So it can be compressive. Okay. So we are applied in such a way. So it can be. So it is also classified as normal strain. Okay. So normal strain again divided into three types. So longitudinal, delta L by L is the strain, right? It is your strain. Okay, again the strains are classified into normal strain and shear strain. So in the normal strain, it will be classified into three types: longitudinal, lateral and volumetric, right? So again the longitudinal means the change in length by original length, but lateral strain means if you applied this load, if you applied some tensile load on this body, so it will extend in this direction and it will reduce in another 2 dimensions, right? So this lateral on the axis, the main axis, it is, if you applied load on the main axis, there will be some deformation in other axis also. So that difference, that is delta D by D or delta B by B, the rate of change in depth or rate of change in breadth is also comes under strain. So this lateral strain is the other direction. So if you applied in one direction, this is longitudinal. If there is a change in another 2 directions also, then it is called as lateral direction, lateral strain. Okay. So it comes under lateral strain. So volumetric strain, the change in volume, the total change in volume, that is delta V by V. The total change in volume is volumetric strain. Okay. So this is the types of strain. So strain has no units, but it is indicated by epsilon E. Okay. So the strain is indicated by epsilon like this. So if it is undergoes in Ex, in x axis it is x direction. If it is undergoes in y direction, it is y direction. If it is in z direction, we will discuss it later, but for time being we need to understand what is load, what is stress, what is strain. That's what important. Okay. Next, material properties. So what is the material property? For suppose this is a plastic, right? Okay. So the plastic can be converted into thin sheets. So you can see how thin it is, right? So if you can convert something into thin sheets, it is called as malleability. Okay. If you can convert a material sheet into sheets, if you convert something, if you can convert into convert something into a thin sheet, then it is called as, such a material is called as malleable material. So for example, gold can be converted into thin sheets. Okay. Next, ductility. If you can convert some of the material, any material, into a thin wires, for example electrical wires or copper wires, wherever you can see the wire nature, if you can convert something into wire nature, those called as ductile materials. For example, steel, copper, aluminum. So these are all comes under ductile materials. So if some materials can be malleable, at the same time they can be ductile. Okay. Next, third material property is brittle. Brittle has no elastic nature. So elastic nature means it cannot be converted into malleable, it cannot be converted into ductile. The failure will be sudden. There is no plastic deformation in this body. So for example, it is glass. Glass will be broken without any warning. So there is no plastic deformation. Okay. The fourth one is creep. Creep is a material property which will, due to the continuous load on a body, it will undergo continuous deformation. Okay. So that means plastic deformation. It cannot regain its original shape with a constant load. A 10 gauges load acting upon a plate. With time it will bend and cannot regain its original shape. It cannot come again into its own shape. That called as creep. Creep is a sustained load or static load or gradually applied load which is acted upon a body. It will turn the body into permanent deformation. That is called as creep. And fifth one is fatigue nature. Due to application of continuous loads again and again, it cannot withstand the pressure. Such a type of material property is called as fatigue due to reversal loads. So these are the main properties, main material properties. Okay. So let us revise what we said in this class. So loads, here loads are classified into based on direction, based on time. If it is normal, if it is perpendicular to the surface, it is called as normal load. If it is parallel to the surface, if it is acted parallel to the surface, it is called shear or transverse load. With respect to time, if it is applied gradually with some time, it is called as gradual load or it will be static. So if it is applied within the fraction of time from a certain distance, it is called as sudden load or impact loads. And again stress. Stresses are classified into two types. Stress is nothing but the resistance offered by a body to the load which is applied on it. So the stresses are classified into normal stress and the shear stress. Okay, if a man standing on a earth, if a man standing on any plane, the plane offers some resistance, that is stress. Stress is indicated by sigma and the Newton per mm square is the units. So here the stress is nothing but load by area. The strain is change in dimensions to the original dimensions is the strain. If it is acted on the normal plane, that strain is called as normal strain. If the shear load acted upon the body, if it causes some strain, it is called as shear strain. So here the normal strain is again classified into three types: longitudinal strain, lateral strain and volumetric strain. Longitudinal strain is the change in length by original length, but lateral strain is the change in other two dimensions. If it is acted on one dimension, the change in the other two dimensions is called as lateral dimension. Whereas in volumetric strain, the total change in the volume to the original volume is the volumetric strain. Okay, so as we go into the material properties, malleability is if the ability of a material to turn into a sheets, that is example gold. Ductility, if you can turn some material into ductile, that is into a wire, that is called as ductile material. If you can turn, if there is no warning sign of failure, the sudden failure occurs, such a material is called as brittle. Due to constant load on a body, it will undergo permanent deformation. Such a type of property of the material is called as creep. And the fatigue means due to the continuous application of loads, the material will lose its ability to take the stress. Such a property is called as fatigue. Okay, so these are the main material properties and simple example of simple stress and simple strain. And let's we go further into what is Young's modulus, what is the elastic properties of the material. Let's we discuss in the next class.